And now we spoke about the people at the OEMs. What about these people in the supply chain? That's going to hurt.
Yeah. If you're producing something like a shock towers, longitudinal members, or some other beams and brackets that are now part of the rear floor or the front suspension system, we have a bad news for you because that part will be gone as soon as Gigacasting takes over.
Yeah, that's for sure. But I'm more worried about the thousands of article numbers in the drivetrain for a diesel engine.
And that's another thing that we need
massive.
to look at, because usually all these Gigacastings are mostly used at the moment for the newer EVs, but they build up the plants right from the start.
Yeah, but come on now.
But it will not take long when they start to refurbish all the production lines, and then we will have it with every car.
Yeah, I mean, what's stopping you from putting a diesel engine with a casted rear floor? Hello and welcome to a new episode of Gold Casting. This is the podcast where we are addressing money, growth, market, not necessarily a lot of technology. And we hope that you that are a previous listener and or a newcomer today will find it interesting.
Especially today, we start a completely new series where we're talking about topic number one in the foundry industry, which is the gigacasting.
We think you will find it interesting, and the reason why we do a series of episodes is that me and Fabian have been kicking this around. We have noted a few things. First of all, there are many aspects of this. Second of all, we see so many people that have interesting insights that we want to interview in our podcast. So this is like the starting episode where we try to iron out the big fields of interest and the questions to be put later on. And then we hope that you will follow us through.
That would be our intention, because we want to take you on a journey from each individual position within the industry. As we see these cards get larger and larger, another pinnacle of our industry. And if you scale it up, it's not a linear scale. The problems grow in size. You need more advanced solution, but also you have the budget for better solutions because your casting is directly fed into the car production line. And we will give you an introduction today and then continue that talk with different experts all around the industry and dig down in all of the issues. So, one disclaimer right away, we will be a bit more technical than we used to in our other episodes.
I try to live with that, right?
Yeah, that's something what we have to do if we want to dig down that rabbit hole.
Yeah, and before going into the rabbit hole, I would like that we discuss a few things first, because why is this so intriguing? And we made a short list here. What we have seen, what kind of differs gigacasting, megacasting, depend on which machine maker you're talking to. First of all, there's a lot of money. There's a lot of budget here. We have never, me or Fabian or any of our colleagues, seen the budget is this big where car companies are actually opening the wallet and digging well and funding well. That is interesting because it opens new horizons as well. The second thing we see, new part, new process, new machine concept, new ways to build a car. There's a lot of new here. Risk level, risk mitigation is also calling for a certain aspects.
Especially this time, it's not a supplier where you could blame it on. It's the car manufacturer operating the foundry themselves and feeding the castings directly into the car production plant. And you don't want to have that stopped.
No. Imagine, it's the typical foundry guys. They talk about the hourly rate, and they go like, oh, Jesus Christ, it's 5,000 euros or whatever per hour. But imagine the cost of not building 10 cars.
Yeah. And then having 1,000, 2,000, 5,000 people just standing around waiting for your machine to drop that casting. Forget the hourly rate of your machine.
Then the third aspect on top level here, before we start to discuss more in detail, a lot of people. I've never seen so many people in one project. New people all the time, and different people roles that you never meet before. All of a sudden, they show up in the foundry.
Also, the fun thing is at the Eurogos, all the presentations where it's about gigacasting, megacastings, these presentations were filled to the brim. And the others, they were like maybe 10-20% filled rooms. So it's the topic that everybody's interested.
And final on top level, which kind of fills me with warmth. It makes high pressure die casting cool again.
Oh, it does.
Right? It is.
Definitely.
It's not only us nerds that like molten metal anymore. It's actually, you see influencers speak about their Teslas built on a gigacasting.
Yep. They talk a lot about giga presses, not die casting machines, but still, it's became cool, and it's something that people talk about that had nothing to do with the industry before. They are Tesla fanboys.
Yeah. So starting to dig in a serious conversation about this from between me and you now, before we have other people that probably knows things that we want to know, and our audience. I would like to start in the corner of a career.
Yeah, especially you see a lot of recruiters out there going everywhere asking people, hey, we saw you're on the high pressure die casting track. Would it be interesting for you? We have that open position, and they send you a list of 3, 4, 5 positions.
Have you ever seen that before, you, Fabian?
No. You see maybe that 1 or 2 headhunters reach out within a year. But for that mega casting, it was basically you could go through the floors of foundries and everybody got a message. It's like reverse Tinder. Girls asking boys to come and join them, but the boys don't reply.
Reverse Tinder. Hey, I met my wife on Tinder.
I met my girlfriend there as well.
You see. So I'm a little bit modern still. I don't have a battery car yet. Yeah, but I think it's interesting. I mean, in the old days, you were supposed to work 15 years in a foundry, getting greased and smudgy and burn your fingers. But I think another thing we can discuss briefly also is the roles that they're looking for. The roles right now, if I start, is anybody who knows something about structural castings. That's cool. That's fine. But that's good. Good for our society. But I see, not in the long run, in this year and the year to come, that we will need to pour in more people, because again, new product, new process, new machine concept, like advanced tooling engineers, for instance. I mean, when did they have an upwind in our industry?
Not really, because usual process is something's wrong with the tool. We cannot do it on site. We send it back to the tool maker.
Yeah, and now how do you send back something that weighs 50 tons and supposed to produce cars?
Exactly. You have to go to every office from the city to get a permit to transport that thing on the road.
And you have to transport what? Between 0.2 in the morning and 0.4 in the morning.
Yeah. And 50 tons is just the insert. It's not the whole die half.
No. I think it's going to be interesting. I think many new roles will find very interesting jobs in this. I think the development will be, if I say 10 years, would you agree, Fabian?
I would even extend it, that we see it 10, 15 years. So that would be something like 2 generations of the classical OEMs with their 7-year lead time for a platform.
Another role, another type of people that I think we will see entering and getting more power and more challenging job descriptions is actually metallurgist.
Oh, yes, because there's so much alloy used, and the properties required are that detrimental to the part, because there's no other path that your load in a crash situation can go as through the casting. So melt hygiene is crucial. And as you have your melting furnace within your die casting cell, so each machine has its own melting furnace and dosing furnace. Getting the metal from A to B in a good quality is quite a challenge, especially when you start up and you have a lot of scrap.
Yeah, you're thinking like that. I'm thinking like properties over flow length. I bet you will be the conference, scientific conferences in 2025, 2026, 2027 will be about this, because having great properties around the in-gate, no problem, everybody can do it. But how do you do far reaching out in the part? We're speaking about 1.5 meters somewhere, and
even up 2 or more meters of flow length if you count the shot chamber within. And then sure, but you also have to, at the end, these fill fronts come together and they have to recombine, and you have to feed that to prevent the shrinkage porosity. So flow length, feedability, hot tearing, these are the things that are crucial, and that's determined by a few elements within your melt. And really fine-tune that. There's a lot of computer power and physical models behind it to determine it correctly.
That leads me into our next. I'm not been eating mushrooms here, or I'm not checking Tinder while we're doing this. I'm not crazy yet, but my thinking is also this: with a gigacasting, I think we will see the entry of a higher amount of people in computer science. Because let's face it, the elephant in the room: you cast something, how can you be sure of the properties?
Yep.
And in the old
The
days,
easy thing is with the matchsticks. You light them. If they light up, it was a good matchstick. But it's hard to sell cars that are burned and
yeah,
pieces cut out for testing. And the
that's
issue
actually
is if you attach test pieces to a casting,
yeah.
you get an issue that if you optimize these bits of the not casting, you don't care about your casting anymore. If you put it at the front, they're always better than the casting. You put it at the end of the filling, you want to put all the dirt out of the casting. So they have to be crappy.
That leads me to the conclusion that we will see people working more with machine learning and how to try to grasp the properties without breaking the part. Because imagine this situation: you're doing something on sheet metal or components that are traveling with boats and trucks days and weeks. Something goes wrong, you have a recall. Then you have a certain amount of cars that you have to take back and do something with.
Mhm.
And that's perfect if you can change the part. This time you cannot change the part. That's problem number one. Problem number two is that you cast it 1 o'clock in the afternoon on a Wednesday. It is actually assembled in a car 1:15 on the same Wednesday. And that means that if something goes wrong, you have absolutely no warehouse transportation, whatever, hindering the amount for the recall to actually explode in your face. So it has to be correct.
Exactly. I think there's a bit of a detour as you go to stamping, and also there will be a bit of machining and e-coating before it goes into the car manufacturing plant, so it doesn't take 15 minutes, but it's the direct route.
Yeah, and if you look at sheet metal, there's no material on the globe that is that defined, flawless, without any impurities, like a rolled aluminum sheet.
Yeah.
It is actually the perfect material from many senses. I'm sorry to say that, but that's the feeling. So getting the computer science guys into it to control the process window, the foundry industry is not that super academic. And how many years did it take to actually start to use simulations in our dairy industry? And now all of a sudden we need smart boys and girls out there that actually walks in, maybe don't know that much about casting, but mount, a CT scan, whatever kind of parameter we have to check. We're going to be back on this. And they have a big hill to climb.
Oh, definitely. Also, the complexity you cannot guess, but when you're standing on the machine, you have like something like 30, 40, 50 different channels of your heating and cooling for each tool half. You have the jet cooler, you have 3D printed inserts, you have squeeze pins, all of that. It's so much that you cannot fabricate it within a few seconds for the tool opening. You need different levels to check it, camera systems, operating procedures to see, especially, for example, spraying. You have, I don't know, I would guess a number, 500 nozzles per side. How do you know the exact amount that's coming out from each nozzle, that you can be sure that you have the lubrication to get your part out? Because if your part is stuck and you have to get it out somehow, that will break down your whole production line.
I can give you a number from a project I'm working with. It's plus 150 jet cooling and channels in the slider. In one slider, 150 plus stuff.
And you have two sides of that, and still a gating and all of that. So,
oh yeah, and that meter in between. So guess what? The number of channels into that poor computer makes it difficult.
and
That's
then
the
you
computer
have to
science
get in
guys,
thermal
right?
cameras as well to see what the surface temperature looks like, and have then image recognition implemented. So there's a lot of things that are way beyond what you did in the foundry industry for years or
Yes.
ever.
Yes. I also would like to speak a little about the employer of all these people. It's not the traditional foundry anymore. To some extent, but the most extent. I mean, if you look at it, I went through a report. It was pretty much every car maker is going gigacasting, with a few exceptions, and they have to place the foundry inside the manufacturing of the car, the vehicle.
Mhm.
These companies are not super casters from the start. Some of them are, but many of them are like sheet metal companies.
Yeah, but for these companies, as you see, especially in Asia, companies just starting up producing cars,
Mm.
having castings instead of the normal supply chain with buying all individual parts, shipping them to tier twos, building groups, shipping them to tier ones, building assemblies, delivering to the car manufacturing plant takes years to build up. Just having a casting right by your production plant gives you the chance to build a car within a few years.
Yeah, you have the power in your hand.
Also for changes, if you see something, oh, now we produce for the Asian market and I want to go to the US, you have to broaden our base to accommodate for the American streets. Yeah, just get a different tool and 12 weeks later you're ready to go. You don't have to negotiate for years and years to your supply chain to get that change done.
Yeah. And if you happen to do something wrong model, you just melt it and then you're done. Yeah, that's quite interesting. So what we're saying is that, to summarize this section, there are great job opportunities for foundry guys, computer guys or girls, tool people, engineering in general, I would say, casting engineering is special. It is injecting a lot of money into our industry. I mean, that's for sure.
Also, if you think of any high-tech application, something like 3D printing your tool inserts for certain areas where you have the highest temperature load, it makes sense using them in such application for certain areas because the cost of that insert or that tool doesn't matter in comparison to your car production line behind.
So, ladies and gentlemen, we're moving into the section where me and Fabian is going to discuss opening for selling new stuff. 3D printing is one of the obvious things. All of a sudden, it will be worth it. It will be easy, and there's a budget. But I see more things here, dear Fabian.
There are so many more things just developed for the mega casting. Something like how to deal with all the data analysts getting down the rabbit hole of what a car production is actually. Because now all the foundries just have the data that the machine provides for you. No one's putting at additional sensors or thermal cameras to monitor something. No, it's just the sensors that are there anyway to operate the machine. And these the ones you take. No, you will have to implement more and more. And being like in an airplane situation, if system one fails, system two has to pick it up
In no time.
in no time. Or give you an alert saying, hey, we are running into that issue. In 3 shots, you will have a bad casting.
These things will be valuable. These things will pay off with, even if you charge a couple of million euros, they will pay off in what, 6 weeks, 12 weeks, anything below 26 weeks. I can bet my
Yeah,
head or a
if you
nice
prevent
dinner and
one
take your word.
recall, that money is well spent. And then comes the cool thing. Then there's the trickle down effect in the normal industry. We see it from the space program in the 60s. So many things we see as a normal product around our daily households are developed for space, like your accu-powered drill that was designed for the space station in first. High torque handheld tools you needed at first for outer space.
I was waiting for you to come into some kind of kitchenware. It would be great because I don't think you're too familiar with everything in the kitchen every day. But okay, the power tools. Yeah, I'm sure. I'm thinking about that small things will matter. So I'm thinking like this: if you develop, for example, a super release agent, you have a new market because it's worth to take it into consideration. It will be a quick route, and my goodness, if you get there, the volumes are huge. I mean, already we see 110 plus contracts on very big machines, meaning 6,000, 9,000, 12,000, and even rumors 18,000 tons, right? So the cost of it will, of course, it's a car industry, but it has never been such an open window to present new stuff like the 3D printing, for example. I bet it will kick off. But I'm thinking also about other things like high thermal conductivity steels. We have heard about them for 5, 10 years, right?
Mhm.
Now, no one will stand in the way to push in that steel for 100,000 euros into a tool to make it last 10,000 shots longer, or release the part better, or whatever you like.
Or segment your tool even more and
Yep.
take all the pieces and have them coated.
Mm.
That now makes also sense because it delivers a longer lifetime of the surface. And if you have some heat cracks on the surface and you have one guy going there and scraping it all off, you don't have the time and money for that.
Which leads me to all the things that needs to be done, right? Where you have a chance. Like, for example, smart tool exchange systems. I mean, we see Japanese foundries owned by OEMs. They change a tool before I can drink a cup of coffee. It's so damn fast. I'm not saying it's going to be that fast to move all these dinosaurs in steel, but it will be a rapid development to get things up and running safely. And if you sell good, better release agent, high thermal conductivity steel, 3D printed cores, a new sort of ejector pin, you name it. The window is here now for 5-6 years ahead.
Also, if you see something that will be changed definitely quite a lot, is something like the plunger or the shot
Oh
sleeve.
yeah, oh yeah.
You have something like a camera lens system to just clip it in. You can go with the next one and then clip it out. I don't know what's gonna be the system, but it has to be something like that. It cannot take you one shift to assemble it, take it out, because on the one hand you cannot lift it anymore. It's way too heavy. You need
Yeah.
crane operations and all of that.
But that's not the only problem with the shot sleeve system, right?
I don't think so. There are many other things, especially when you put something like 80, 120 kilograms of liquid aluminum in it.
In the same
That's a
spot.
lot of temperature load
In the same spot.
on one spot. And also for the plunger, just moving it, you don't want to have as tight as a gap between the plunger and the shot sleeve. And if you have an uneven thermal load, to have it evenly distributed without having edges and get the plunger getting stuck, that's a very high load and high intensity.
Yeah, and I hear rumors that some companies are actually changing the shot sleeve every shift. I don't know if it's true, but I hear those rumors, and everybody hear the rumors. But yeah, it's an open window. It's a new market, that's for sure.
Oh, definitely. We should open up a shot sleeve company.
Have I said that I haven't done it? I think my
Oh,
I think my friends at Bühle will be a little bit upset.
no.
I kind of understand that they're surviving with some short sleeves and spare parts and stuff, and me going in there and and saying hello, you can buy it from Staffan, 15% decrease discount. Yeah, I mean it.
And it only takes me 8 weeks instead of 12.
And then you wait until there's a crisis somewhere, and then you increase the price. Yeah, but I think that's one thing. So we have covered that it will be a lot of job opportunities. It will be a lot of opportunities for people selling things or developing things, getting a budget for if you have something promising and you want to try it. I mean, we see it popping up, right?
Yeah, even if you sold something, staying with them and developing into a system that actually delivers a benefit, that's something where the big value is. And then you can use that system that you improved massively and sell it as a solution to the other foundries.
That kind of gives me an idea of a very fun job in an insurance company. I don't think this job is invented, but imagine if you're an insurance company and these cars cannot be repaired after a crash, right? When a car company is going to be insured, there are some certain contracts. I've been in this for dangerous radio, as we call it, when you have radio remote lifting heavy things in public places. So these insurances are pretty difficult to actually underwrite, as it's called. Imagine this one, and imagine being that expert, saying to Tesla, Volvo, Mercedes, whoever, yeah, sure, but do you have so we know that you are sound in your production, because otherwise this insurance will not apply.
Your customers have to pay way more. And yeah, you can remove certain bits, but the overall stiffness of the car comes from the structure itself. And if you divide it into sub-segments, you lose a lot of the stiffness. That's just mechanics.
That's mechanics, but what I'm saying is that insurance companies probably are going to start to employ foundry guys and metallurgists. Take that in for a minute. It makes sense.
Yeah, but when we talk about the threats, there's also another one. We talked about a lot of new jobs will be generated. And on the counter side, we also have a lot of jobs that are not needed anymore.
Where do you want to start?
If you see one gigacasting replace something like 70 pieces, you need something like 50 supply chain managers. You don't need them anymore.
No.
This whole purchasing organization can shrink down to few people because there's not too many parts, not too many of suppliers. It's most of that is in-house.
I heard a number. I was in a meeting, quite high level actually. They let me in that room, believe it or not, and it was, you know, everybody had a tighter strategy, blah blah blah, production, blah blah blah. Important people, right? And they started to discuss this, and they came to the conclusion: this is a mid-segment car maker somewhere in Europe. 30 million euros was the saving on the people you just mentioned.
That's a big number. Especially great that you can mention the numbers, as we have so many NDAs around that you already signed.
I kind of feel that one is safe, and I'm pretty sure that it goes for all car makers if they start to do the math. And we work with a lot of car makers, so be my guest trying to pick that one out. But anyway, 30 million euros, what does it mean? It is actually a great margin increase on a bunch of cars.
Especially you reduce your overhead and employ people that are really making an impact on you. So you take in a lot of the production load and you cap the profits that the suppliers make, take that in-house, reduce your overhead. And that's something we've seen with the Teslas. As soon as they scaled up their production, their cars got cheaper and cheaper. The Model Y I'm driving is now more than 10,000 Swiss francs cheaper than when I bought it.
You always are the smart guy in the room, huh? I was speaking with this guy. He was selling massive insurances for steel plants, and we have a few steel plants in Sweden, as you know. And then we were drinking a few beers. It was up north, and I kind of asked him, "How do you know how to set the premium?" And he said, "Well, you know, we work for weeks and weeks and weeks and weeks, but end of the day, what we do is calculate how many people are working in a plant and divide it by the tons of steel produced. The more people, the more mistakes, the higher premium."
Interesting approach.
You will find the same thing in this, that you cannot have a lot of foundry guys, you know, walking around and say, "Well, in the 80s what we did." Oh, you need facts. You need a different set of people, different everything.
Yeah, but it's funny because I published an article just today, and one of the guidelines how to deal with things you don't know is find rule of thumbs. They're not accurate, but they give you a ranking.
Yeah, that's why I think the Germans have a problem with the gigacastings, actually, because they want it to be perfect and precise. Let me put it this way: I haven't heard any project reaching and completing the specification set up in the beginning of the project.
How should that be done? It's with every project where you do something really technology that's completely new, that's out of the scope of your thought about when you made the specification. You can only reach a high quality level by doing it.
Yeah.
There was one study, I don't know which American university, and it was a pottery class. And yeah, hear me out. One class, the professor told them, you have to make one pot for the whole semester, and I will judge that pot, so make it the most beautiful. The other class, he told them, make as many pots as you can. I don't care about the quality. At the end of the semester, every pot from the class that made hundreds of pots was better in quality than the one just making one.
Because they've been practicing.
They've been practicing and finding issues, solving issues. And you cannot have that on a desk somewhere in an office. You have to just do it, try it. And when there's an issue, try to fix it.
I kind of agree. And now we spoke about the people at the OEMs. What about these people in the supply chain? That's going to hurt.
Yeah. If you're producing something like shock towers, longitudinal members, or some other beams and brackets that are now part of the rear floor or the front suspension system, we have a bad news for you because that part will be gone as soon as Gigacasting takes over.
Yeah, that's for sure. But I'm more worried about the thousands and thousands and thousands of article numbers in the drivetrain for a diesel engine.
And that's another thing that we need to look at, because usually all these Gigacastings are mostly used at the moment for the newer EVs, but they build up the plants right from the start.
Yeah, but come on now.
But it will not take long when they start to refurbish older production lines, and then you will have it with every car.
Yeah, I mean, what's stopping you from putting a diesel engine with a casted rear floor? Nothing.
Nothing. Maybe just there's not enough room to put the foundry next to your older car factory.
Yeah, then you close it and you start a new one somewhere in
Yeah.
Uzbekistan or
Or
somewhere.
you build a long tunnel
You build a long
where you can hover the cars, the Gigacasting through into your production line.
but with 30 million euros in saving on people in the quality department, purchasing department, you can build quite a long tunnel.
Exactly.
That's not the problem.
Another thing is that we have to discuss is the terms of sustainability. You're not carrying parts all around the world to manufacture in one car. You just bring the alloy to a plant, melt it there, cast it, and you save so much in carbon footprint by using that. Also, as it's one large casting, it's quite simple to recycle.
That's good, but I have a really bad one for you. The kilograms of the car goes up. That we know, right?
Yeah,
What?
massively. I think somewhere in the range of 25% weight increase just in aluminium in the next 5 years.
Great. But the amount of aluminum that goes in that car that has a demand of higher properties, meaning ruling out most of the scrap on the market, is increasing dramatically. You have a rear floor of 50, 60 kilos, right?
I'm around that.
Yeah, you have a battery tray, blah, blah, blah. That's another 40, 50. They all have aluminum silicon 7 or aluminum silicon 10, whatever. They need an allocation, everything from 7 to 11%. Try to do that with Twitch, which is what comes out when you scrap a normal car. You take that old Opel that is 17 years old, or my old Volvo, for example, and everything is done in ADC 12, 226, 46,000. What are we going to do with all the scrap? So here comes the thing.
Before we go into that, let me explain for all the not material expert, what does that mean? These are all alloys that have very high contents, for example, like in copper. You don't want to have too much copper in your alloys, as it's for the corrosion resistance not that well. And also the other something like zinc. For these alloys, nobody cared about the properties. They just have to be there, and it shouldn't be plastic. And now you have a casting which is really depends on the properties, where you really need to handpick every element that goes in there. So you also have to handpick your scrap, and your scrap probably is more expensive that goes in there than the primary aluminum.
And you have a big pile of cars to be scrapped every year that contains that eutectic 10, 12, 13% silicon, a lot of copper, a lot of iron.
And then if you go to the sheet metals where you have to add the silicon, which is quite dirty, they have a very high iron content. You cannot use too much of that as well.
No. So revolting back to it, if you want to make money in the car industry upcoming years, be a scrap dealer. Find good sources of scrap and start to sell long contracts. And the other thing is that today and yesterday and the year before, and for quite a while, 50% of all aluminum used has been primary alloys, right?
Yeah.
Especially for sheet metal and extrusion. Now everybody is working on sustainability, CBAM, everything is coming. The problematic thing is that if you increase the weight of the car with 50 kilos of casted aluminum, but you increase the amount of alloy in the car that has to have high properties to 100 kilos, how are you going to get this in a sustainable way when the only place you can find decent primaries, around 4 kilos carbon dioxide per kilogram alloy, from Norway and Canada?
There's quite a limiting factor.
It is.
And especially it comes down, aluminium needs a lot of energy to go from the aluminum hydroxide to pure aluminium. And the only way to get that in a sustainable way is by water power. And that's something you find in Norway. That's something you find in Canada.
Exactly.
And your bauxite mines where you get the aluminum hydroxide are mostly in Australia or in Brazil or somewhere far away. So you have to transport them via ship all the way to the north of this globe and then ship it from there again around the world. So there is a lot of developments going on within that primary production plants to reduce the carbon footprint, as a big impact on that is the electrodes you use besides the energy.
So what I'm saying, for sustainability reason and our dear globe, this is not good news.
there's another team of experts needed developing a totally different process
Yes.
that we can have still the sustainable cars.
But if you're sitting on the on the drawings of a nice nuclear facility in Europe, start to build quick because you will sell that energy. Believe me.
Oh yeah. But I think that's not a perfect time to wrap it up, as we talked about various things all around that. And when we go down each rabbit hole, we will have an interview partner. So this is part 1 of the series of many to come. Follow for more. And I can tell you, just this week, we have 2 more interviews scheduled.
Stay tuned. And if you have some thoughts, some ideas, some aspects you want us to bring up, shoot us a line. Send a
Or
text.
even if you have a solution that the world should know about, let us know.
We interview you. We will surprise you anyway with a question that pops up in our mind when we do the recording.
That will be so. Then we'll see us in the next one. Have a good day, and don't forget to subscribe.
Thank you. See you. Bye.
Goodbye.